Slope formulas. You've got a slope formula if you're given 2 points, and you already know this. You've seen it 100 times. y2 minus y1 over x2 minus x1. That's a slope formula if you're given 2 points. But if you're given the standard form of the equation, remember standard form was ax plus by equals c. If you're given that, you might not know how to find a slope with an equation, but you've got a slope equation here too. Negative a over b. Notice those capital letters. Those are indicative that they're the coefficients from that standard form equation. And basically, if you were going to take that standard form equation and put it in slope-intercept form, that's the same thing. That's exactly what you would be doing if you're putting in slope-intercept form, looking for that m number, looking for the slope. So example 3, find the slope. You've got 2 points, so this is just your slope equation. All right, you have an x and a y and an x and a y. All that equation tells you is take the second y number minus the first y number over the second x minus the first x. Anytime I see a minus minus, I'm going to add the opposite there. Combining the top, I have negative 10. On the bottom, I've got 4. And of course, you're going to reduce your fraction. That reduces to negative 5 halves. Part B, y2 minus y1 over x2 minus x1. Add the opposite. 0 over 8 is 0. Think about what kind of line has a slope of 0. That's a flat line, right? Flat line. Go back. What kind of line has a slope that's negative? That must be downhill. Okay, downhill line, flat line. Part C. y2 minus y1 over x2 minus x1. Add the opposite, add the opposite. 30 over 0. Okay, 30 over 0 is undefined. That must be a vertical line.
So if it's over 0, it's undefined?
Yes, 0 on the bottom is bad news, right? It's undefined. It won't work on your calculator. That's talking about a vertical line. Can't talk about slope. It's undefined. So then part D. Part D is the first one that has that's standard form. And so we had this formula, m equals negative a over b, remember. That's the one we're probably not as comfortable with. It's easy to do, but hard to remember, I suppose. What you could do is just move your stuff around and put it in slope-intercept form. But that's what this formula is basically doing. Your a number is 4 and your b number is negative 5. So m is going to equal opposite of 4 over negative 5. Reduces to positive 4/5. Positive slope means it's going uphill. Say that again.
The 20?
Nope.
Okay.
The 20 is basically just, I mean, if you think about it, it has to do with putting the y-intercept wherever it goes. Okay, so it might be higher or lower up on the y-axis once you think about the y-intercept. Good question. Average rate of change describes how much a quantity changes. A positive value indicates an increase and a negative value indicates a decrease. It is an application of the slope formula. So you're going to see a rate of change problem, or you're going to see a story problem, and it's going to look super complicated, but basically it's just the slope formula. In 2010, the government spent that amount of money on research. In 2013, the government spent a second amount of money on research. Find the average rate of change in the amount of money spent on research. So what I like to do is think of this as ordered pairs. In 2010, they spent this amount of money in millions. And in 2013, they spent this amount of money in millions. So it's really just two ordered pairs, average rate of change. We're talking about the slope. We're going to find the slope between those 2 points. So y2 minus y1 over x2 minus x1 and here I'd probably use a calculator. I don't want to do that in my head. 8,658 minus 9,547. You're going to get negative 889 million over 3, and that's 3 years. Okay. So that may or may not be reduced, but when we're doing average rate of change, we want to know what happens in per year, basically. Okay. So how many million per year? So I would take my calculator and divide negative 889 divided by 3. That's going to be about negative 296.3 million per year. That's the average rate of change. So then they want me to graph the data and interpret the result. So let's start by just graphing those points. Okay. If I was going to graph those points, I might want to label the axes, and it doesn't really matter. You can do it a different way if you want to, but I took 2010 and then I skipped 2 and I wrote 2011. I skipped to 2012, skipped to 2013. You can do it different than that if you want to. It doesn't really matter. I just wanted to spread out my data. And then on the other axis, you basically needed to go up to 10,000 million. So each mark was 1, 2, 3, 4, 5. That was 5,000. Oh, he doesn't like writing there. 5,000 million. And then 6, 7, 8, 9, 10. That's 10,000 million. And of course, that's in dollars. So I graphed that point. In 2010, it was basically 9.5 right there. Dot. And in 2013, it was basically 8.6. So there-ish, I suppose. So I wanted a line segment right there. Graph the data as a line segment. Okay, got it. And interpret the result. I'm not sure I really needed the graph to be able to interpret the result because I already had that slope formula. We can tell it's decreasing because the negative 296 tells me it's decreasing, but of course I see the graph is decreasing. So interpret the result. We might say something like the amount spent is decreasing by an average of 296.3 million. I'll put a dollar sign in there. Dollars each year. And again, I didn't need the graph to say that. As soon as I saw that number, I knew that.